Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question from Statistics 1 May 2023 paper. So let's see what's the question number 2 from this paper is about. So basically the concepts behind this question, it's from correlation and regression that has been discussed in chapter number 5 of your Statistics 1 textbook. So in order to be able to solve this question and in order to understand the solution, you should have done this chapter number 5 and you should have practiced questions from that chapter. So let's get started with question number 2. So two students, Olive and Shan, collect data on the weight W grams and the tail length T centimeter of what? 15 mice. Okay, so two students, they collected the data for what? Weight and the tail length. Weight is represented by W grams and tail length is represented by T centimeter for how many? 15 mice. So here you can see the some statistics is given. These are summarized here, like S of TT, the value for S of TT that is 5.3173, sum of W squared which is 6089.12, sum of TW is given as 2304.53, sum of W it's given as 297.8, and sum of T it's given as 114.8. So now part A asks to calculate the value of statistics S of TW and the value of S of WW. So we need to find out the value for these summary statistics. Fine. So let's consider part A. We need to find out the value for S of TW. So S of TW is what? Sum of TW minus sum of T times sum of W over N. This is the formula. You can check it out from it will be also given in the formula booklet. Okay, so sum of TW is basically 2304.53 2304.53 minus sum of T. Sum of T is given as 114.8 times sum of W. Sum of W is given as 297.8 over N is how much? The value for N is given as 15, isn't it? Yeah, 15 mice. So the value for N is 15. Now just calculate to get the value for S of TW. This is 2304.53 minus 114.8 times 297.8 over 15. So the value for S of TW, it's basically 25.3673 something. So basically they took up to 2 decimal place. You can see that they took up to 2 decimal place. Okay, so we can give the answer to 2 decimal place or at least 1 decimal place. Okay, since they didn't mention anything, so we can give the value to at least 1 decimal place, that is 25.4. 25.4 is the value for what? S of TW. Okay, so this is 1 decimal place. Fine. Okay, now next they asked to find out the value for what? S of that is S of WW. Okay, so the value for S of WW, the formula is what? Let me show you the formula. Like most of the students feel difficulties remembering this formula, so no problem, you can check it out directly from the formula booklet. It's given in the formula booklet. So sum of S of XX, not sum, it is S of XX, summary statistics for XX, this is sum of x squared minus sum of x whole squared over n. Okay, so we need sum of w. In that case, sum of w would be what? Sum of w would be sum of w squared minus sum of w whole squared over n, right? That would be sum of w squared minus sum of w whole squared over n. N is what? N is 15 there. Okay, we will write it in the next substitution. So sum of w squared is what? Sum of w squared is given as 6089.12. So 6089 point what? 1 2 is the value for sum of w squared minus sum of w. What's the value for sum of w? It is 297.8. 297.8 whole squared over n. N is basically 15. Okay, so what would be the value? 297.8 whole squared over 15, then 6089.12 minus the answer. So it gives you 176.79 something. So like as that summary statistic, they gave the value minimum, it is 1 decimal place, right? So let's round to 1 decimal place. There is 170. Okay, 1 decimal place or 3 significant figure. Basically the one we considered earlier, it was 3 significant figure, isn't it? So we can write it to 3 significant figure, okay, rather than decimal place, because the process is that if the value is not, if it is not mentioned like how many decimal places or significant figures to be considered, then generally you will consider always 3 significant figures. So this is basically 3 significant figure. That's what we considered. Okay, it's not 1 decimal place. So here it would be what? 176.797. It keeps going, which can be rounded to 3 significant figures as 177. What? It is up to 3 significant figure. So the one which I considered earlier, 1 decimal place, like by watching on the given values, the decimal places considered in the given values, it is basically followed in physics. In case of physics practicals or physics questions, we follow like this. In maths, if the significant figure or the decimal places is not mentioned, what to consider, then you will give the answer to 3 significant figures, always 3 significant figures. Okay, so that was part A from this question. So next is part B. In part B, they are asking to calculate the value of the PMCC, basically product moment correlation coefficient between W and T. So from chapter 5 we have learned about that the value for PMCC between 2 variables, it's given by R equals to what? S of since it is W and T, WT over S of WW times S of TT, right? This is also given in the formula booklet. You can check it out from the formula booklet. It's given in the formula booklet. The product moment correlation coefficient is, this is the formula basically. Okay, so S of xy, since we have W and T as the variable, that's why we have to write S of WT over square root of S of WW times S of TT. Done. So what's the, now we need to just put the values. So S of WT, what was the value for S of WT? The value for S of WT that we found here, it was 25.4, right? So we need to take the exact value. So this is 25 point, okay, we can keep it, we can use 25.4 since it's difficult to get the exact value now. So square root of s of ww times s of tt. Okay, s of what's the value for s of ww? We got here, which is 176.797. Okay, I have this value saved, so we can use this value directly. The exact value 176.797. It keeps going times. The more the exact value you use, the more accurate answer you will have. Okay, so the value for s of tt it's given as 5.3173. 5.3173. Okay, so now calculate the value. 176.797 times 5.3173 square root answer, then 25.4 over the answer, so you will get 0.828419 something. So we will round up to 3 significant figures, so 82841, it keeps going, so we will basically round up to 3 significant figures to get 0.288. Done. This is basically part B. For part C, they are asking to show that the equation of the regression line of W, the equation of the regression line of W on T. The regression line of W on T can be written as W equals to negative 16.7 plus 4.77 T. Okay, that means we need to find out the equation of regression line of W on T, right? So regression line can be basically, regression line equation is always in this form, W equals to but A plus BT. It's also given in the formula booklet. Okay, so that means we need to find out the value for A, that is the intercept, and the value for B. Okay, so let me show you from the formula booklet. You can find the value for like this equation here, right? At here it's given. Okay, so B is s of xy over s of xx. So we have in the equation in this form, A plus BT. Okay, so B would be s of WT over s of TT, right? So the value for B is what? S of WT over S of TT. So for part C, the value for B is equals to what? S of WT over S of TT. So what's that value? Check it out, the value for S of WT. The value for S of WT, we got that in part A, that was 25.4. so let's use 25.4 over S of TT. It would be better if we could use the exact value, but here it is rounded, so we have to use the rounded value, or we can take 3 decimal place here. So 176.797, the value for S of TT. Is this the value for S of TT? No, the value of S of TT is 5.3173. It is 5.3173. So that would give you 25.4 over 5.3173. That is basically 4.776 86043. 7. Okay, so we got the value for B. Now the value for A. So we know that W bar can be written as A plus B times T bar. Okay, how did I get this formula from? Look, this is also given in the formula booklet. You can get it from here. Look, A equals to Y bar minus B times X bar. Okay, so that means A can be written as what? Y was W, so W bar minus B times T bar, right? So that's what we will be using here to get the value for A, that is the intercept. So A is what? W bar minus B times T bar. So W bar is what? How can you find out the W bar? Sum of W over N. Sum of W is 297.8. So 297.8 over 15 minus B, use the exact value of B, times T bar. What's the value for T bar? Sum of T over N, right? Which is 114.8. 114.8 over what? N is 15. This is T bar. So what would be the value? Let's calculate it first. 4.7768 something times 114.8 over 15. We need to subtract it from what? 297.8 over 15 minus the answer. Okay, so you will get negative 16.70557. okay, negative 16.7057188. This is the value for A. So the equation we will have here, this is W equals to, they gave the values to three significant figures, right? Negative 16.7 and 4.77. Negative 16.7, right, up to three significant figure. This is negative 16.7, and the value for B we got 4.78. But they said what? They said here 4.77. This is because we considered the rounded value for S of WT. Okay, so if you use the exact value, you will get 4.77 T. So that's why I said try to use the exact value for what? The statistics, for getting an accurate answer. Okay, so let's consider the exact value of S of WT. From here we need to calculate it. S of TW, which is 2304.53 minus 114.8 times 297.8 over 15. So that would give you 25 point, this is basically 25.3673 333. It keeps going. There are 5 threes. Okay, this is the exact value. I got saved the value in my calculator. So this is 25 point what? 25.36. It keeps going. Okay, so this value over 5.3173. so you will get exactly 4 point what? 7701 something. Okay, 4.77. let me write the exact value. 0716968. Okay, so always deal with the exact value to get the more accurate and perfect answer. So that's what they have asked for in part C, and we have showed it correctly. Done. Okay, next, part D asks to give an interpretation of the gradient of the regression line. So we need to interpret the value for the gradient, like what does the value of the gradient represent. Okay, so the value for gradient we got here, which is B equals to 4.77, right, the coefficient of T. So what does it mean? Gradient means the rate of change, right? That means if the tail length T, like according to the context of the question, T is the length, tail length. So if the tail length increases by 1 centimeter, T is in centimeter, you should keep that in mind. So if the tail length increases by 1 centimeter, okay, the interpretation is if the tail length what? Increases by 1 centimeter, then the weight of mice what? Increases by how much? Increases by the gradient. The gradient was 4.77. This is up to 3 significant figure. That much what? Grams. That's it. That's basically the interpretation of the what? gradient, and that's how we need to interpret the gradient, like based on the context of the question. Fine. So that was part D. Okay, next is part E. So in part E, they asked, explain why it would not be appropriate to use the regression line in part C to estimate the weight of a mouse with a tail length of 2 centimeters. Okay, so why it would not be appropriate? So let's see, like for tail length 2, let's put t equals to 2. If tail length is 2 centimeters, then t would be what? 2, right? So for part E, consider the tail length, t equals to what? 2. If t equals to 2, then weight, what's the value for the weight? It's basically negative 16.7 plus 4.77 times what? 2. So that would give you a negative value, isn't it? That would give you a negative value. Yes, it's negative 7.15 something, okay, which is less than 0. Okay, hence weight can't be negative, isn't it? Can weight be negative? Never. Weight cannot be what? Negative. Okay, since weight cannot be negative. Okay, there's some grammatical working. Okay, since weight cannot be negative, therefore the estimation would not be what? Appropriate in this case. That's what they have asked for in part E. Okay, so next is part F. In part F, before part F, they have said something. Shan decided to code the data using x equals to t minus 6 and y equals to w over 2 minus 5. Okay, so Shan has coded the data using this coding formula. So part F asks to write down the value of the PMCC between x and y. We need to find out, like, we need to write down the value for the product moment correlation coefficient between x and y. So if you have done chapter number 2 from your statistics 1 textbook, then definitely you know that for coding, for a coded data, basically if you code a data, then the value for PMCC is remains unaffected. That means coding a data doesn't change the value for the PMCC. So the value for PMCC would be what? In this case, for part F, the value for R would be what? It will remain as it is. So what was the value for R earlier? It was 828. So that would be what? 0.828 up to 3 significant figures. That's it. Because what? PMCC is not getting affected due to the what? Coding. Fine. Okay, next is part G. In part G, they're asking to write down an equation of the regression line of y on x. We need to write a regression line, an equation for the regression line of y on x. Okay, regression line of y on x. That means in place of w and t, we need to have what? X and y, right? So since the data has been coded, right? So that means we can substitute what? We can substitute the coding formula directly into the regression line equation, right? So in order to substitute, what we need to do, we need to make t the subject and w the subject from the two equations. So if you make t subject, you will get x plus 6, t equals to what? X plus 6. And if you make w the subject, that would be, let me check, w over 2 minus 5. Okay, so take 5 to the left, that would give you y plus 5. So 2y plus 10. So w equals to 2y plus 10. So w equals to what? 2y plus 10. Now we need to just substitute the two codes into the regression line equation. So this is negative 16.7 plus 4.770. So w, in place of w it would be what? 2y plus 10 equals to what? Negative 16.7, if I'm not wrong, 16.7 plus 4.77t plus 4.77 times, what's the value for t? This is x plus 6. Okay, this is what we got, the regression line equation for what? In terms of x and y. Okay, so regression line equation of y on x. So do we have y on the left hand side? Yeah, we have y on the left hand side. This is enough for 2 marks. If you just keep it in this form, this is enough to get 2 marks. And that's all about part G. They said, because they said already, you do not need to simplify your equation. I didn't write it like I didn't read it earlier. So they said you do not need to simplify your equation, you just need to keep it in substituted form. That's enough. So this was all about the second question from Statistics 1 May 2023 paper.